Hey guys, I'm just back with another name reaction, that is your Beckmann's rearrangement. In my last video I just told you that I'll be uploading questions regarding that name reaction, but I changed up my mind now, and then I thought, why not just start another name reaction, and then after teaching a few of them, I'll just collect all the questions of all the name reactions and then put it up in one video. So I think that would be better. Without wasting time, let's just start with this name reaction. And for this Beckmann's rearrangement, generally what happens here is that there is an oxime, and it is the substrate, and with this, if we add a Lewis acid, uh, as the reagent, if we add this Lewis acid, then the product that we get is the amide, and this is basically the reaction, right? When we add Lewis acid to an oxime, the substrate, we get the product as amide. Now the thing is that the Lewis acid, it can be anything. That's not of that can be any Lewis acid, right? It may be sulfuric acid or phosphorus pentachloride or phosphorus trichloride, or anything. All right. So now, first of all, to prepare this oxime, we need to know how to prepare the oxime, as sometimes there may be some exams, like there may be some places where they will like to make the question a little tricky, and they would not give directly the oxime, and we need to prepare it first. So let's start with the preparation of the oxime. For that, we'll need a carbonyl compound. It may be just a carbonyl compound, any carbonyl compound, right? So let me write down the name for you here. Carbonyl compound. And to this, if we add hydroxylamine is NH2OH basically. So I wrote H2 here just for the sake, for convenience, and NH2OH. So, and if the pH is at control pH, if we make this to react, what happens is that this water, it comes out, and then as a result we get the oxime. So this is so simple, as simple as right. So we get this your oxime. Okay, so now let's proceed to the reaction. So and this hydroxylamine is an ammonia derivative, and here nucleophilic addition took place, and then we got our oxime. Now the main part starts, the reaction. So as I told, oxime, no, so let's just put the oxime here. This is the reaction basically. Okay, so I'll be writing down the reaction here. So this is the oxime, this so this is the oxime, and with the oxime we'll add any Lewis acid, as I just said. So let me just take sulfuric acid for now, and then from the sulfuric acid there is this H positive, no? So, and then what we get as a result is we get this as the product. This is an amide, right? So now without wasting time, let me just teach you the mechanism for this. This is a very simple reaction, right? So the mechanism is very quite a simple one. Basically what happens that carbon to nitrogen migration takes place, and the migrating group also, it retains its stereochemistry. The stereochemistry does not change over here. So okay, let me start with the mechanism now. So for the mechanism, what you have to do is just take the carbonyl compound. Okay, so I took this, this is the carbonyl compound, right? And then suppose there is this sulfuric acid, no, or any, suppose if I take even the pentachloride or anything. So this is a Lewis acid, so this is a OH will definitely take up this H positive, and then as a result what we'll get is OH2 positive here, and then the two alkyl groups are like this. All right. Now as we know that this is an electronegative atom, and it cannot bear a positive charge, so it will definitely want to lose this positive charge. So, and it also will become a good leaving group. Therefore, when this group, the group that is trans to this OH2, this group comes and migrates over this nitrogen, nitrogen with this nitrogen, then it becomes a good living group and it leaves. All right, or am I going too fast? I don't think so. Okay, so yeah, after this what we get as a result is that carbon positive charge will be here, and then since we migrated the group over there, so here is this your R2 and here is this R1. Okay, so and in any kind of reaction always this water is used, workup is done, I mean to complete the reaction and so we took this water just got attached over here in the positive center I mean, and then what we get is C double bond and R2, and with this this attached, right? But now since again this oxygen attached to this, so it will have this positive charge now just as I said again, the same thing happens, right? So this is the electronegative atom and it cannot have this positive charge, it cannot take this positive charge, I mean it cannot bear the positive charge, so definitely this hydrogen will leave and then this bond shifts over here. As a result what we get is your R1C, here will be the oxygen, this is the hydrogen, no more positive charge over here, this nitrogen, and this is this. So you can see I can just name it like 1 2 3, all right, and then something a reaction takes place, tautomerism takes place, and then what happens, this bond hydrogen, this shifts over here, and then this bond breaks and shifts over here. As a result I can just write it like tautomerism is taking place. I will be teaching tautomerism very soon. This is a very easy concept, although a very important one. So yeah, I think we got our answer, right? R1C double bond O and R, and here there is this H. Isn't that easy? Pretty easy, right? Okay, let me just revise it once again. You see what actually Beckmann's rearrangement is what you take an enzyme, add Lewis acid to it and you'll get your amide. So yeah, that's pretty much the thing we need to know. So but to prepare the enzyme we'll need a carbonyl compound and hydroxylamine, and when we add this two at controlled pH, water comes out and we get our enzyme. So now what happens, this enzyme, it takes up this Lewis acid, the OH takes up this Lewis acid and it bears this positive charge. So then this group that is trans to this OH group, it comes and attacks nitrogen and then this leaves. So the thing occurs like this, and then there is this water attacks again in this positive center, we get this, and then since it has again the positive charge, so hydrogen leaves and this bond shifts over here, we get this tautomerism, tada. So the answer is here. So yeah, I'll be doing some of this name reaction very soon. I hope this was useful and helpful to you, and I think I taught this in a very easy way, and I'll be also teaching some tricks to solve this kind of name reactions in minutes. So yeah, I hope this was helpful. So please like this video and comment down below how if there is some suggestion you want to give, and please subscribe to my channel. Okay, thank you.